And this is the start of the Parlon Experiments Mark III. It's my third iteration of this particular setup. First two being in 2009, obviously before I had this account, and in 2013, which I've covered in a video posted last summer. There's the main feeder transformer for everything, or the feeder transformer, which I've covered in previous videos. There's the feeder line mounted to a tree there. Top it on the insulator because it's 1,200 volts above ground, and the wire insulation is obviously not rated for that. There's the second one that's at ground potential, so it's just wrapped around a wood screw. That's the first load drop, 50 watt 75 volt train lamp. That's just a type 1490 3.2 volt 160 milliampere 512 milliwatt lamp, being used as an idiot light just to say that the thing's live. That I've got connected to the filament windings. That's running on about 1.9 volts, hence why it's a lot dimmer than normal. But its main purpose is as an indicator, so all it needs to do is just produce a bit of light so that it can be seen that it's operating. And then that bit of zip cord just runs down to this light, which is another 50 watt 75 volt train lamp or feeder wire. And this is the current end of the line. This is a transformer board that I threw together earlier today. Couldn't find a box, hence the exposed receptacle, but I will be rigging that up with a box in the near future, hopefully, knock on wood. That's just a 23 watt General Electric killer crap. A Payco focus. It's a Payco transformer 9100-0350. Couldn't find any information on that, but it looks like 9100 is just a standard transformer part number prefix for them. Looks like they were bought up by Hewlett-Packard, hence the bought up by Hewlett-Packard, hence the two groups of 4 numerals part numbering. Focus, come on. Very uncooperative. And there you can see the markings on it. I'm just feeding it through the 1150 volt tap. It is rated for 50 cycles per second minimum operating frequency, all the way up to 1,000 cycles per second. So my feeding at 1,240 volts isn't that much of an issue, because the 20% increase means that the flux loading is still lower than it would be if we're feeding it 1,150 volts at 50 cycles per second. There's just some of the wiring. Again, this is just an experimental thing, nothing really permanent, by the way. Risk of electrocution, do not attempt at home. You can see the insulator, because I need to do that because that wire isn't rated for 1,200 volts AC. I think it's either 600 or 1,000 volts insulation, probably 600. And of course also the exposed wiring. We'll be getting a box for that. And anyways, other loads, that's a 10 watt Philips L-Prize lamp. And there's a Philips 12.5 watt LED. It's, I think, one of their ambient LED or Endura LED lamps. They go by a couple of different names. And of course, no longer sold. So yeah, I'm using a couple of collector lamps, but fortunately these LEDs are, being just plastic and metal, if they drop, they don't really break, unless you drop them off, you know, many stories of a building. But from typical hand height, isn't much of an issue, knock on wood. And this is just the remains of the 2009 experiment, which just used a pair of microwave oven transformers, and the line was actually running at about 2,000 volts. Of course, also meant it couldn't be operated continuously because microwave oven transformers aren't designed for continuous operation at their rated potential. But at least for that arrangement, I was able to run mains loads. Whereas the microwave oven transformers, as I'm using them now, about a 40% reduction in the core flux loading. Yeah, they're only operating about 60% of what they are at regular mains potentials, but their losses are still fairly high. Although nowhere near what they are regular mains because the core isn't saturating. But anyways, course, then again, back then I didn't have, my collection was substantially smaller than it is now, and of course I didn't have any 75 volt train lamps to use them with.